Hello and welcome to GIS. Today in this video I am going to show you how to merge multiple dams using the technique called Mosaic in ArcGIS as our primary GIS tools. After that we are going to explore some of the different surfaces that can be made from dam, namely slope, hillsides, contours in the upcoming video, and then determine or quantify different characteristics of slope, hillsides, and contours. So the first thing that we have to do is actually create a seamless dam. It's really common when we download dam from the online sources. So I have downloaded 4 different dam tiles from USGS Earth Explorer. You can see the previous video in which downloading of dam is shown. The study area can be such a big file size that they come in tiles, and the tiles need to be stitched together because the surfaces need to study as one continuous piece of information. In order to do that, we need to have couple of these tiles. So go to Add Data in Standard Toolbar and click on it. The Add Data dialog box is displayed. In this dialog box, browse to the location and select all these 4 different tiles and then choose Add button. The dialog box is closed and the tile has been added here in this table of content and also in the data view area. Okay, now you can clearly see that we have individual dam tiles. And then I'll create a seamless raster by using the technique called Mosaic to New Raster. So go to search and click on it. The search window appears. In this window, type Mosaic to New Raster in the search area and then press enter. And then click on the first option, Mosaic to New Raster. Mosaic to New Raster dialog box is displayed. Or you go to Arc Toolbox and click on it. The Arc Toolbox appears. Mosaic to New Raster is available under Data Management Tools. So expand Data Management Tools. And then in Data Management Tools, expand Raster. And in Raster, expand Raster Dataset. So here you can see Mosaic to New Raster is available. So just double click on it. Mosaic to New Raster dialog box is displayed. Now before going forward with that, I'm just going to highlight some things. Over here in this dialog box, we have to specify pixel types and spatial reference for the raster, which are optional. Also, we need to specify number of bands. So in order to see this information, go to table of content and right click on any one dam tile. A flyout is displayed. From this flyout, choose Properties option. The Layer Properties dialog box with source type chosen is displayed. In this dialog box, we have number of band as 1, pixel type as signed integers, pixel band as 16 bits, and then scroll down. So here you can see the spatial reference, that is the XY coordinates as CSWGS 1984. So just keep all this information in mind and then choose OK button. The dialog box is closed. Next, in Mosaic to New Raster, we need to first add the input raster here in the input raster area. So for that, go to table of content and select all the 4 different layers by pressing Ctrl and then drag all the 4 layers to input raster area. So here you can see all the 4 layers are displayed. Next, in the output location, click on the folder icon. The output location dialog box is displayed. In this dialog box, browse to the location and then select the folder that is the Mosaic raster and then choose Add button. The dialog box is closed and the output location is specified here in the output location area. After that, in raster dataset name with extension text box, type Mosaic dam and then we need to specify the extension as well. So if you are not sure about the extension, just go down and click on Show Help button. At the side of the dialog box, it will show you the possible extensions. In this case, I'm just going with diff So just type .tif here in this text box and then click on hide help button. So the information about the text box will be hidden. In the special reference for raster text box, just click on special reference icon. The special reference properties dialog box with XY coordinate system tab chosen is displayed. In this dialog box, expand layer folder and then choose CGS WGS 1984 and click OK button. The special reference properties dialog box is closed and the special reference is specified here in this text box. Next, in the pixel types, click on the down arrow. A list appears. From that list, select 16-bit signed, which you have already seen in the layers properties dialog box if you remember. And then in the number of band, type 1. After that, in mosaic operator, click on this down arrow. A list appears. From that list, select blend. Scroll down a little bit and we have mosaic color map mode. So just click on this down arrow. A list appears. From that list, select match. For the last two options, if you would like to play around with the options that are available on the list, then just click on show help. It will actually explain what the mosaic operator does. And then in mosaic color map mode, just place the cursor here and you will see the explanation of mosaic color mode option. So in this case, I am going to stick with blend and match options and then click on hide help button. Once all the informations are given here on this dialog box, so just click on OK button. The dialog box is closed and it will take a little while to generate the mosaic raster. Alright, the seamless dam has been created successfully. That means the line which was there here has gone. Now just turn off the old ones and we have one working dam here. We can see the maximum and minimum values for this. Now go ahead and remove all the old tile. So just right click on the tile, a flyout is displayed. From this flyout, choose remove. One tile has got removed, so similarly just right click and click on remove. Again right click, again click on remove. Similarly, remove all this. Only you need this mosaic dam layers. And at last change this color scheme to something else. So for that go to table of content and click on the color ramp. The select color ramp dialog box is displayed. In this dialog box, click on the down arrow of color ramp. A list of color ramp appears. From this list, select maybe this color. Click on the checkbox corresponds to invert and then at last choose OK button. The dialog box is closed and the color theme has been changed here as you can see. So this color scheme is most appropriate for this dam file. So that's all. I hope you like the video. Stay tuned. Hello and welcome to GIS. Today in this video you will learn how to analyze and assess digital elevation model. How to download the digital elevation model at free of cost has already been explained in previous video. Today let's assess that digital elevation model. Open ArcMap first and then add the data that is downloaded. So for adding the data, go to Add Data in Standard toolbar and click on it. The Add Data dialog box is displayed. In this dialog box, browse to the location and select the dam file and then choose Add button. The dialog box is closed and the data has been added in the data view area and also to the table of content. Next, go to Tools box and click on I button, that is basically means identify, and then click on the dam. The identify dialog box is displayed, which contains information about the pixels. The information that we get is 632, that is the pixel value. 632 basically means the elevation of a particular pixel, that is the elevation of a particular location is 632 meters above the sea level. Now close this dialog box by clicking on this cross. Next, let's understand the assessment and analysis of digital elevation model. Now let's say if you want to create a contour passing through a particular pixel, just select Create Contour option from 3D Analysis tools and then click anywhere on the dam image. Again click somewhere else on the dam image. So here you can see the contours are being created. After that, remove the dam from the data view. So for that, go to Table of Content and click the checkbox corresponding to dam. The dam layer is got removed from the data view area and you have the contours that is just created. But however, the contours are in graphical format which cannot be used for any analysis purposes. So primarily we need to convert these things into shapefiles so that we can use it for any analysis purposes or in some other softwares. Now select both the graphical contours by holding Ctrl button. After that, go to Drawing Toolbox and click on the down arrow next to Drawing. A list appears. From this list, select Convert Graphics to Features. Convert Graphics to Features dialog box is displayed. In this dialog box, click on the down arrow next to Convert and ensure that line graphic is selected. Also ensure that data frame radio button is selected. But if you have lots of layers in table of content and want to specify a specific layer, then select the radio button next to this layers and source data and then select on the down arrow next to it. A list appears. From this list, select a specific layer. But as there is only one layer in table of content, so just click the radio button next to data frame. Now define the output shapefile or feature classes. Basically in this we'll define the location and the file name. So I'll keep it as default and then click on OK button. Convert Graphics to Features dialog box is closed and Convert Graphics to Features warning box is displayed, which tells us that whether you want to add the shapefile to the data view area. So just click yes. Now the shapefile has been added to the data view area. And go to Table of Content and remove the shapefile from the data view area by clicking on the checkbox. And then select both the graphics by holding Ctrl button if not selected, and then right click on the data view area. A list appears. From that list, select delete. So the graphical features has got removed. Now again go to Table of Content and click the checkbox corresponding to the shapefile that you are looking for. In order to see the elevation, just right click on the Convert to Graphic. A flyout is displayed. From this flyout, select Open Attribute Tables and you can see the elevations here in this column, and then click on the cross to go back to the table of content. Similarly, you can create any number of contours in the data view area using digital elevation model. So in the upcoming video, you can see how to create any number of contours. Next, create the aspect map. So for that, go to Arc Toolbox and click on it. The Arc Toolbox is displayed. In this, expand 3D Analysis tools and then expand Raster Surfaces. In Raster Surfaces, double-click on Aspect. The Aspect dialog box is displayed. In the Input Raster area of this dialog box, click on the down arrow and select the DAM file. And then in the Output Raster area, click on the folder icon next to it. The Output Raster dialog box is displayed. In this dialog box, browse to the location and type aspects in the name text box and then click on Save button. The output raster dialog box is closed and the output raster location with the name is specified here in this area. After that, click OK button in aspect dialog box and it will take a little while to generate the aspect map. Again, go to table of content and click the checkbox corresponding to the dam. So here you can see the aspect map has been generated. Now just remove the shapefile, remove the dam from the data view, zoom into it. So here you can see clearly the aspect map. So these are pretty simple things. You can select hillshade map or slope map or etc. which will be shown in the upcoming videos. Now go to table of content and remove the aspect map from the data view and add the dam file. After that, go back to 3D Analysis tools and there is a function called interpolate line. Just select that and draw a line to the dam layer. This particular function gives you the elevation profile of the area along this line that you have just drawn. After that, go to 3D Analysis tools and click on the profile graph. The profile graph title box is displayed. In this graph, you will get the information of the elevation profile of the line that you have just drawn. So this is the elevation profile of the line. After that, click on the close button in profile graph. The profile graph title box is closed. Again, go back to 3D Analysis tools and there is another function called create steepest path. Every pixel in this image will be 8 neighboring pixels. So the waterfalls in the particular pixel will flow in the one of these 8 directions. The steepest path will indicate the steepest slope direction from the point of query. So just select create steepest path and select a particular pixel over here as an example and see the steepest direction from this pixel. After that, again click on profile graph. The profile graph title box is displayed. In this profile graph, you can see the direction of the steepest path and then close this profile graph title box and click another pixel and then click on profile graph. The profile graph title box is displayed. So in this profile graph, you can see the direction has changed. So this is the profile graph of this particular pixel. So here you can see the steepness graph has changed in this pixel. Now close this profile dialog box. Go back to 3D Analysis tools and we have an option called View Shade, that is the create line of sight features. So just select that. The line of sight dialog box is displayed. In this dialog box, you can specify the observe offset or the target offset, that is the Z unit. You can set any one of this, but I'll keep it as default and then draw a line. So the line is drawn. Say for example your eye is here and what is that you can see in this line. So click on profile graph. The profile graph title box is displayed again. In this profile graph you can see the line of sight. Let's say your eyesight is here and the eyesight goes like this. Whatever is below this point could not be seen. Close this profile graph. So these are the primary function of 3D Analysis. Now close this line of sight dialog box and delete these both lines. So select these two lines by holding Ctrl and right click on it. A list appears. From that list, select delete. So both the lines are deleted. And you can do further analysis on dam. Go to table of content and right click on the dam layer. A list appears. From that list, select properties. The layer properties dialog box with general tab chosen is displayed. In this dialog box, select symbology tab. In the color ramp area of this tab, click on the down arrow. A list of color appears. Let's say choose this color and select apply button. So here you can see the color has changed and this will give you better view of the digital elevation model. Next, select the classified option in the symbology tab of the layered properties dialog box and change the color in the color ramp. Now in classified option of this symbology tab, you can see the ranges are being available here, which means that all the elevation ranges from 358 to 499 will be displayed in white color and 703 to 827 will be displayed in brown color. This is primarily to classify digital elevation model into certain sets of classes of elevation. So click on apply and then click on OK button. The dialog box is closed and the color has been applied here, as you can see. And here you go, this is the digital elevation model legends in the table of content. That is primarily about the analysis and assessing of digital elevation model for further use. You can definitely explore more options in 3D Analyst or Spatial Analyst, etc. etc. So that's all. I hope you liked the video. Stay tuned.